Hello folks, best wishes for CAT. We're doing this a couple of days before CAT, just before the exam. And so, unusual, we generally don't do this. There is no good reason for having this session. I'm sure several of you, I don't know if you guys are live, you guys can see me, hear me, I don't know, I'm not checking audio, video, nothing. And so, call it a little bit of a joke. I don't have a clear good reason why I'm doing this. I had two ideas in my mind which I definitely wanted to tell before CAT, and through a series of classes it slipped, and it gnawed away at me, and I said, look, I can't put a session and say, look, we'll have a class for all 2IM students and do this, and I'll be seriously cheesed off if there were a question that was based on one of these two ideas. I don't want to then run that risk and turn away, do something silly against luck gods, that to this short, this close by to the exam. So just in order for myself to sleep easy and say, look, I thought of this idea, I have said this out, and let me not jinx anything, we're doing this session. Kind of 10 minutes, 15 minutes, nothing more than that. Couple of ideas in geometry, and then we'll be done with it. And so one very simple, very nice idea. It's a proof actually. And so, oopsie. And so, I'm sure several of you have heard of this proof. I have a chord AB, the tangent PBQ, angle between tangent and chord is equal to the angle made by the chord in the other segment. This angle is equal to this angle. That's the idea. Right? So how do we prove that? There is a tangent PBQ, the center of a circle O. So OB is perpendicular to PQ, tangent is perpendicular to radius. So OBQ is 90 degrees. So this is 90 minus x. This is 90 minus x. Why? Because an isosceles triangle, 2 radii. 90 minus x, 90 minus x, this is 2x. Why? Sum of three angles is 180. This is 2x, this is x, because angle at the center is twice angle on the segment. And so angle between tangent and chord is equal to angle made by the chord on the other segment. It's called alternate segment theorem. I didn't start off this whole session and say, look, let me go on live on YouTube and do something for this. I want to build on this a little bit. We will. And so we have that funda there. Then we say, hey, nice. No. Right. So there's a tangent PT and a secant PAB. You know this nice, beautiful theorem which says PT square equals PA into PB. Right? Nice idea, beautiful idea. And then we're going to say this is linked to the idea we discussed in alternate segment theorem. How so? Join this chord AT, right? And then the angle between chord and tangent, this angle x, is equal to angle made here x. Nice, fun to idea. This angle is x, this angle is x. And so now, if you take triangle PAT and triangle PTB, these two triangles, this angle is common. Angle PTA is equal to angle PBT. These two triangles are similar to each other. That will give us PA by PT equals PT by PB, or PT square equals PA into PB. So we use the idea of alternate segment theorem, know that these two angles are equal, put that in this diagram, and then we say, hey, nice, interesting. Therefore, now we know that these two triangles are similar. Which triangle? PTA and PBT are similar. Two angles are equal, they're similar. Therefore, we use similarity, and then we prove PT square equal PA into PB. Do we really need to know this? No. Right, but it's an interesting idea. I didn't want to miss out. Right? There's one more idea that I wanted to check. I wanted to discuss this, which is nice. PT square equal to PA into PB. I'm just having one look on the chat window. One other idea which I was very interested in kind of drilling through. When we know this beautiful, with A gives lends itself to 2, 3 very interesting interpretations which come of use very frequently. Fine. Half into base into height. What I'm going to do, I'm going to use that idea and say, hey, we have this triangle ABC and we have a circle inside that. This is called an in circle. Center of that circle is I. Nice. And we say this is in circle, the circle just inside the triangle. The sides of the triangle will be tangents to this circle. And so if I join this point, ID, where it touches the circle, this will be 90 degrees. Tangent perpendicular to radius. This will be 90 degrees, this will be 90 degrees. In radius, in radius, in radius. Nice. So now we know area of a triangle is half into base into height. So we can say, oh, nice, interesting. If this side were A, opposite A, this were B, this were C, area of triangle BIC is half into BC into ID, half into base into height, or half AR. Right? Nice. This would be half BR. This would be half CR. Or now we say, I'm going to add the entire triangle's area up. I'm going to say area of triangle ABC is equal to area of triangle BIC plus AIC plus AIB, or this is half AR plus half BR plus half CR, or R into half of A plus B plus C, which is RS. This standalone is not spectacular, not one earth-shattering thing. You know this formula. Area is R into S. You know how to link this up. Just one small extrapolation here, which is super useful. This is the idea here is if you have any polygon, not necessarily a regular polygon, area of any polygon is semi-perimeter into Inradius. Sometimes we miss out on this. Why so? We have a center here with radius, 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 radius. All of these are triangles. Add all of the areas of all the triangles, we'll get area of the polygon. Need not be a regular polygon, need not be a symmetric polygon, need not have all angles equal, nothing. Any polygon, if there is an incircle to it, then this will work. It's a very extrapolation of that idea. Fine, nice, interesting. Final thing in area of a triangle. Area of a triangle is half into base into height. So this is side A, side B, side C. Altitude to A, altitude to B, altitude to C. Okay. And very interesting. Two kind of very interesting takeaways from this. First thing is half into A into HA equals half into B into HB. They're given two sides of a triangle. We know one altitude, we can find the other one. And so, because the areas are equal, sometimes we just forget that we can match areas of like this. So sometimes if you're given right angle triangle, we're asked what is the altitude to the third side. Very often we say, we call this as x, 13 minus x, and then we plug in Pythagoras theorem and simplify. We don't need to do that. Area is half into 5 into 12, which is equal to half into height into 13. We found h. So area is half into base into height. That's very powerful. Right? Final thing, we know ratio of sides of a triangle. We know A is to B is to C. This is nothing but 1 by HA is to 1 by HB is to 1 by HC. A into HA is B into HB is C into HC. So if you called each of this half into A into HA equal to half into B into HB equal to half into C into HC is equal to area. Then area by HA is A by 2, area by HB is B by 2, area by HC is C by 2. So A is to B is to C is 1 by HA is to 1 by HB is to 1 by HC. It's a reciprocal relationship. Super useful. So we know sides of a triangle are in the ratio of 4 is to 5 is to 6. And the question could say, what are the ratio of the altitudes of this triangle? 1 by 4, 1 by 5, 1 by 6, then simplify, we are through. And so this idea that heights and altitudes have this reciprocal relationship is important. This idea that area of any polygon that has an inch circle inside a semi-perimeter into Inradius is important. Right? So anyway, I'm going to stop here. I'm not going to take so much of your time. The day before exam, 2 days before exam, it got stuck in my head, and I didn't want to, as I said, I didn't want to anger the karma gods. And so it occurred to me that I was very keen to talk about these two ideas a while ago, and then I completely forgot about it. I said, look, I want to figure out some way of saying, hey, let's do this. And the only way available now is just go live on YouTube and pitter patter for some time. I'm not going to take too much time. Best wishes, all of you. Enjoy yourself. Have fun in the exam. Go wearing a big smile. We'll catch up with you on that side. The exam on 27th. Best wishes. Cheers, guys.